understanding multiple regression, and why it exists. When people try to explain outcomes in markets or business, they often rely on a single explanation. Interest rates moved, earnings changed, sentiment shifted, but real outcomes are rarely driven by just one force. Multiple regression exists because reality is layered. Prices, returns, and valuations respond to many influences at the same time. Instead of blaming one variable, multiple regression allows us to examine how several factors contribute simultaneously to a single result. The goal is not prediction alone. The goal is understanding structure. We want to know which forces matter, how much they matter, and how they interact when everything is moving together. Without this framework, analysis collapses into storytelling, where whichever explanation sounds best wins. At the center of multiple regression is the idea of isolation. Each coefficient measures how the outcome changes when one factor moves, assuming all other factors remain unchanged. That assumption does not describe the real world perfectly, but it creates structure. Without it, comparison becomes impossible. This is where many people go wrong. They read coefficients as unconditional truths, instead of conditional relationships. A coefficient does not say what usually happens. It says what happens under a very specific condition. When interpretation ignores that condition, confidence replaces understanding. Regression simplifies reality so that disciplined comparison becomes possible, not so that certainty can be claimed. Adding more variables does not automatically improve a model. When explanatory variables are related to each other, they share information. The model must decide how to divide their shared influence. Remove one variable, and the others absorb its effect. Add it back, and estimates shift again. This sensitivity is not a flaw in the math. It reflects overlap in reality. Good modeling is not about including everything that moves. It is about choosing variables that belong together conceptually. Mathematics cannot fix poor reasoning. Statistical significance alone is not enough either. A result can be statistically strong and practically meaningless. What matters is whether the size of an effect changes decisions in the real world. Finally, regression does not establish cause. Two variables can move together because they share a trend, respond to a hidden driver, or simply coincide. Strong statistics do not prove explanation. Causal interpretation requires logic, timing, and reasoning beyond the model. Regression supports thinking, but it does not replace it. Used correctly, it helps us understand complex systems without oversimplifying them. Used carelessly, it creates confidence without insight. The difference lies entirely in interpretation.